So let's start off with Stefano. If you would share your screen, and as Andre just alluded, Stefano was just awarded a major $26 million National Science Foundation Center, along with, I believe it was University of Pennsylvania and a couple other partners. I hope you'll talk about that. And we will, and then we'll go to Stavros and then Josh, and then I'll go after that. So about 6 minutes each.
So good morning, everyone. My name is Stefano Carpin, and today I will talk about the research we do in agrobotics at UC Merced. And I want to acknowledge that I've been working in robotics for something like 20 years now, perhaps. But this really started, I really started to get interested into this domain 5-6 years ago, and mostly because of citrus and our director, Josh Fears, who will speak later. And I think Josh has a slide about where Merced is, and the peculiarity of our location is actually the fact that we are surrounded by high value perennial crops, specifically almonds and vineyards. And I'm screening this video to remind us about the scale of the problem we're dealing with. These are massive amounts of cultivated land. And one of the problems we keep hearing from farmers is that it's very difficult to have enough manpower to do everything that needs to be done in farms. And robotics is seen from their end as a great way to help them out. So the issues we are mostly focusing on are related to sensing. I don't do any work, or I don't do a lot of work on the actuation side. And so detecting pests in the farms early on so that they can be treated when it's the best moment before they spread. Issues related to irrigation, which is of course a very topical problem in the Central Valley, and given the recurrent drought events that you are experiencing in California. And the other thing is weeds, of course, that has been discussed quite a bit in the previous panel. Most of my research is done in collaboration with other people who do drones, because I'm not a drone person. So most of what we do is actually deploy small experimental vehicles where we can test out ideas and then hopefully transition them to bigger vehicles that could be used for continuous operations. So when you go out in the field, there was interesting proposition about autonomy in vineyards and orchards and in the field later on. It's a different environment. It is easier. It has its own challenges as well. A lot of unforeseen things happen in these domains. The way I see it, we have a lot of interest in precision agriculture, and this is a robot going through almond orchard, and it's interesting because a lot of the things that are happening in an almond orchard cannot be detected if you fly a drone over it. You have to drive a robot around, and everything I think has been said with regard to the importance of detecting data and detecting actionable data. So where are the water leaks happening? Which are the trees that are having problems? Are there weeds, and so on and so forth? So this is more or less the kind of system that we envision. Deploying a robot through these these very large orchards, in very often parts that cannot be sensed with drones only, and then returning to the farmer actionable information. So we've been doing this for a number of years. I'm going to spotlight a couple of projects we have. The first one is robot-assisted precision irrigation delivery. And I like this project because it involves all the panelists. And as in this panel, it's myself, Ken, Josh, and Stavros. And so without getting into the details and the weeds, no pun intended, the deal is that when drought came in 2015, we had a lot of interesting conversation with wine growers. Grape growers, and they pointed out that the irrigation infrastructure is still suboptimal in the sense that very often water is delivered without considering the inherent heterogeneity in the soil. And so we thought if there could be a way to somehow do some modifications or to the existing irrigation infrastructure and develop some sensing systems that could lead to a more efficient water use. And so in a nutshell, the idea is to use drones to fly over vineyards, then through deep learning, trying to understand which areas are over-irrigated or under-irrigated, and consequently then deploy robots that could somehow make adjustments to a appropriately upgraded irrigation infrastructure. And this is funded by the US Department of Agriculture as part of the National Robotics Initiative. As Ken formerly alluded to, we just landed a very large grant from the National Science Foundation and the Engineering Research Center. This is a grant with 4 universities. The lead is Penn, and it's together with the University of Florida, Purdue, and UC Merced. And it is IoT for agriculture, and it spans a lot of different domains, but it revolves around 3 pillars: data acquisition, data transmission, and data processing. So it's all about data. And the part about data acquisition, that is quite some work being done on the robotics side. So I've been working in this domain for a while. I think that the challenges are, from my point of view, are the following. The user interface, these systems ought to be simple to use. Robustness, when these systems break down, they are in a remote location. They need to be easy to reach and hopefully not break down too often. And then the lack of infrastructure, mostly communication infrastructure. And the last one is the most important one, keeping the farmers engaged throughout the process to get their input. And I think I spoke for 6 minutes, and I'll be happy to hand it back to Ken.
Perfect. Thank you, Stefano. I would just want to say, if you're noticing a strange video behind me, I'll explain this in a few minutes. But and I'll get rid of it because it's giving me this weird hair aura. But to Stefano, let me ask you about the question about cost. When you talk about challenges and IoT, there is one. Many people have talked about the idea that we could put lots of devices out into the field, remote. Independent autonomous valves to control irrigation and also sensing. And what are your thoughts about this? Because I know that cost is very sensitive, and Jim was just alluding to this as well on the farm. What are your thoughts about reducing costs?
That's a very good question. In particular, if you consider these massive scales, if you think about, okay, I'm going to put a sensor on every tree, how many hundreds of millions of trees are in California? So that drives how inexpensive should this sensor be. I think that the one way to look at that, which is perhaps related to what we were doing with Rapid, is that rather than putting expensive infrastructure, expensive infrastructure in the field, you could put an expensive infrastructure on a mobile device that then will serve different part of the field and then can be continuously upgraded as opposed to putting down an infrastructure that then will be there for years and will need to be maintained and so on and so forth. It's absolutely vital. And every time we talk with farmers, I think we're lucky being in Merced, we can get to hang around with farmers quite a bit. Cost is one of the first things that pops up. The bottom line matters, and so I think that the 3 things we hear more is water, availability of labor, and how much it's going to cost. These things have to add up. It's absolutely important. Okay,
great. Thank you, Stefano. All right. Well, let's see. Stavros, if you could share your screen, I will go to you next, and I have many more questions. And one of which, just to keep in mind, we'll come back to, is the time constants. It's very interesting to me that in so many problems in robotics, we deal with very fast time constants. And as Jim pointed out, in the driving on self-driving vehicles, time constants are very, very short. We have to make decisions very rapidly. But it's interesting that in the field, the time constants are very long. Plants take quite a long time to mature and evolve. So I'm curious about how you're all thinking about that in this context, how that changes the sort of challenges and framework for what's feasible in machine learning and AI applications for agriculture.